back to our shared screen here. Okay, let's try this again. When we are first introduced to trigonometry, we are introduced to trigonometry using right triangles. So we see something like this and we learn that mnemonic device of SOHCAHTOA, which is all great to learn our sine, cosine, and tangent. And so in this picture, we know the relationships of sine of angle A. So if we're focusing here, that tells us what is our opposite side, what is our adjacent side, what is our hypotenuse. And then we can set up these ratios of our opposite side over our hypotenuse, etc., for sine and cosine of tangent. Well, when we're looking at these, it says, that we're supposed to use like opposite and hypotenuse and adjacent and hypotenuse. But if I draw a triangle here that does not have a right angle at C anymore, I can understand what the opposite side is, but which one's my adjacent and which one's my hypotenuse. And that makes all of these really hard to set up since they all use an adjacent and a hypotenuse in them somewhere. But it doesn't mean that we can't find those relationships and the angle measures, etc., of a triangle that's not a right triangle. They're just not straight ratios like we were taught before when there is a right triangle. And that's where our law of sines comes into play. These are what are known as oblique triangles. The word oblique just means that one of our angles is not a right angle. So the triangles that we will be working with will no longer be right triangles. We already have all techniques needed to find our missing parts of a right triangle. There is a special case, and that's what we're going to look at on Wednesday, and we'll talk about what makes this a special case. So basically what you need to understand is all of the ones we see today, we don't have to worry about this special case happening. We are going to avoid all of those today. And we're going to focus on a certain setup of triangle that will allow us to use what is called the law of sines. So the law of sines. The law of sines says this, that the measure, first of all, understand the notation here. This angle A is always going to be noted in a capital letter. The side across from an angle will be noted using the lowercase version of that angle. So the side across from angle A will be noted lowercase a. The side across from angle B will be noted lowercase b, and the side across from angle C will be noted as lowercase c. And what you see on the law of sines is the ratios of the side across over the sine of that angle. So what you'll see is we've got three ratios here, and all that is showing you is that it works for all combinations. You would only ever use any two of these. So we may set up the first two. Okay, that might be what we use. Or you may set up the second two. Okay. Or you may set up the first and last. So you could do the side A over sine of A equals side C over sine of angle C. It doesn't matter. You'll always use two of them to set up a proportion. As long as it is the side across from the angle in the denominator, you have set it up correctly. Any combo of those three proportions will be a true equation. We will know three of these things, may not be those three things, but you'll have one unknown out of those four spots. And we will use then the ratio and how we set up the proportion and what we know about algebraically solving a proportion to solve for the missing piece. Today, I do not have a ton of examples, and so we're going to really slow down the two examples I have and making sure that we are good to go on our calculator with those examples. Stop me if you have questions. Either put them into the chat or unmute yourself and talk to me as we go through this. So on our first example, we are going to do one missing piece. what I want you to look for when you are doing the law of sines is somewhere in here. To be able to do the law of sines, you must know one angle measure and you must know one side across from it. If we don't have that piece of information, law of sines will not work for us, okay? So starting here, we know this ratio to be true, that 5 over the sine of 38, we have both the side across from an angle that we know. And we can use that then to help us find something that is unknown, which in this case would be like this 61-degree angle across from this side B. And so we can set up the other ratio as our unknown side B over the sine of the angle across from it, 61 degrees. Okay, so from here, it is a little bit of a getting to know our calculator and how to type this in. Now, in a proportion, I'm going to kind of speed this up a little bit in just a second. We'll come back to this here, but let me show you real quick how algebraically you probably were taught how to solve a proportion, and that is to do what's called cross multiply, is that we would multiply this direction and multiply this direction, which is absolutely true. So we would end up with 5 times the sine of 61 will equal B times the sine of 38. And then trying to solve this, B is our unknown. Here's our question mark that we're trying to solve for. And it's right now B times the sine of 38. And so we would divide by the sine of 38 on both sides. And our sine of 38 would simplify with itself on that side, and we would find out that B is going to equal whatever 5 times the sine of 61 divided by the sine of 38 ends up being. Now, when we see things like the sine of 61 and the sine of 38, going to my calculator, those end up being very ugly numbers, which is why we're going to try to avoid doing too much in our calculator and trying to round too much. So let's go to our calculator now. I want to look at how I can type this in to avoid as much rounding as possible. Now, I'm going to do this a couple times because we have different types of calculators out there. If your calculator is similar to mine, oh, back up, guys. Everyone hit your mode button. You need to be in degree. All of our angles are 38 degrees, 61 degrees. Everything we are doing right now is in degree mode. And if you are not in degree mode, it will give you the incorrect answers here. Okay, if you have one of the newest operating systems and you are able to hit alpha y equals and get the fraction option here that you can just type into the top of the fraction and the bottom of the fraction, I would pick to just type that whole thing in like we just saw. So I'm going to go ahead and do that. So it was 5 times the sine of 61 divided by the sine of 38. And I would type all of that in at one time and hit enter. If you do not have that option, when you hit alpha y equals, so again, how did I get to that? I hit alpha y equals, and I picked option 1, which is just a normal fraction. And then I typed in and I arrowed up and down to type that in. When you hit alpha y equals, that is not an option. This is another way you can type it in, is you just have to be a little more careful with your parentheses. I can do the numerator, which is 5 times the sine of 61 degrees. And I need to make sure to close the parentheses on that before I divide by the sine of 38 degrees. Will give me the same answer. Okay, will you please put into the chat if you are having trouble getting that done on your calculator? You should be getting an answer of 7.1. I'm going to flip back to my iPad here. Okay, so we just got then that B equals, our side length of B equals 7.1 was our missing side. Now, we're going to talk about some triangle basics here that I want to just remind you of as we are heading through this section here. So triangle basics that can help you with just making sure that you are getting appropriate answers. First of all, I told you that one of the keys to doing these problems is that you have to have a side across from the angle where you know both the side and the angle. If I don't have that, it kind of depends on what I'm missing. If I draw this same exact picture that we had, hold on just a second here. If they didn't give me a side across from an angle like here, right now I've got an 81 degrees across from a side that has nothing marked on it. The 61 is across from our unknown of B. Notice we do not have anything marked here at angle A like we did in the first picture. Okay, so again, I don't have my side across from my angle like I had before. Triangle basics that I want to remind you of is that the angles add up to 180. So if we know 2 out of the 3 angles of a triangle, we always know all 3. I can just take 180 minus the angles that I have and find our missing angle of 38 degrees, which is what it was previously. Another triangle basic that I want to remind you of is that the biggest side is always across from the longest side is always opposite the largest angle, and vice versa. Your shortest side is always opposite your smallest angle. Why do I tell you that? So that you can understand that you got an appropriate answer. We just found across from a bigger angle, a bigger side, right? 61 degrees is bigger than 38 degrees. Therefore, the side across from it, which we found to be 7.1, should be larger than the side that was across from the 38. Let's pretend that we had gotten something like 2.1. Well, that can't be the right answer because it shouldn't be shorter than 5. Okay, so just reminding you of some things that you learned back in geometry that can help you realize whether or not you have an appropriate answer for that particular missing part. All right, again, I'm going to pause here. I have only one more example before I am going to ask you to be able to solve some of these on your own. This was just a single missing piece of a side here to kind of ease our way into law of sines. Any questions for me so far? Go ahead and unmute or put them in the chat. We are going to then move on to the only other example I'm going to do for you guys today, and that is what is called solving a triangle. Okay. After this, I'm going to ask for you to do these problems. So solving our triangle here, we are looking at a side angle, which is one of the ones we are able to do. I want to talk about the directions that say solve. When it says to solve a triangle, that means to find all missing parts. Well, in a triangle, there are 6 parts. There are 3 angles and there are 3 sides. And I'm going to erase this here in just a second, but if I were to like draw out in this picture, we've got angle A, angle B, angle C, and then we've got side A, side B, and side C, what you're going to find out when you're asked to solve a triangle is that you will always start with 3 pieces of information and you will have 3 unknowns. So if I fill in what I know from that picture, I know angle A is 46 degrees. I know angle B is 63 degrees. I know side B is 56 units, whatever that is. And again, one of the little keys to this is you will always have a set of angle across from side, or will be able to get from that. And this is your key that will show up in all your law of sines proportions, is we'll always go back to the one that we knew at the beginning without rounding. So this sine of angle B underneath side 56 will always be what we go back to. Okay. So notice we have 3 unknowns. Those are what we are going to fill in as we do this. And I will tell you the easiest thing is always to fill in your missing angle. So to start with, I would find my third angle, and that would be remembering the fact that the triangle sum is 180 degrees minus the angles we know, 46 degrees and 63 degrees. And when I do that, we should come up with 71 degrees. So we've now found one of our 3 missing parts, and we can mark that in our picture as well. So again, going back to our key here, we started out with 63 degrees across from 56, side of 56. That's going to be the basis for any missing part. Other than this, it doesn't matter which side you find first. Since A is listed first, let's go ahead and find side A here. So again, using what's across from it, 46 degrees here, side A is here. So we will use 56 over the angle it was across from, so sine of 63 equals our unknown side A over sine of 46. Now, on our last page, I want to go back to this. So before you jump into solving this, if I can slide back to our last page here, we did a little bit extra work. You don't necessarily need to do the cross multiply. One other way we can look at this is if I had set it up here, think about, again, algebraically solving, is that I want B by itself, and right now it's B divided by the sine of 61. Well, if I just multiply both sides by sine of 61, we get to this fraction right here, because again, my sine of 61 will cross off on this side, and I've got that sine of 61 multiplying straight across the top, straight across the bottom here, and you get this fraction down here. So that's what I'm going to show doing on this next page. It just saves us a little bit of time here. Is I want A by itself, and to do that, I must multiply both sides by the sine of 46. And when I multiply fractions, I multiply straight across the top, straight across the bottom. So we're looking at A equal to, always put the 56 first just to make it easier to type into my calculator. Okay, so now I'm going to go to my calculator and type in that fraction. The directions did say to round our sides to the nearest tenth. So when I type in that fraction of 56 times sine of 46 and then divide it by the sine of 63. Again, guys, don't go round those numbers. Type them in with the trig expression sign and everything to avoid, at all costs, avoid as much rounding as possible. Get as close to our correct answers as we can. And we're going to do a little, again, calculator check here. When I type that in, we should be getting an answer of 45.2. And it did say around to the nearest tenth, so I'm going to go to one decimal place here, 45.2. Let me know if we're having trouble getting to that. Okay. Now, this part of the proportion that we used to set up to find A, use that again. Guys, 56 and sine of 63, those were not rounded. I would definitely avoid using my new rounded answer. because it's rounded. And when I use a rounded answer to find another answer, if I can avoid that, I will. Not always avoidable, I understand that. But if we can, I'm going to stick with the things that were handed to me at the beginning that were not rounded. Okay, so that's now what I'm going to use to set up to find side C. So again, using the 56 over the sine of 63, side C, which is my next focus here to find, over the sine of the angle across from it, which is 71 degrees. Again, solving, I'm just going to multiply both sides by the sine of 71. I'm going to go to my calculator and type in that fraction, 56 times sine of 71 divided by the sine of 63. And get my last answer. And my last answer on this, again, typing this into my calculator, we should be getting 59.4. So solving the triangle, I know I have a lot of things written up there, but let me show you very specifically. I have 3 answers to solving the triangle. Angle C, side A, and side C. Those were my 3 unknowns when I started, so those would be my 3 answers to what it means when it's asking me to solve the triangle. Okay, from here, this is what I would like, is I'm going to give you 2 more problems that involve solving the triangle. One is going to be very similar to the one we just did, where I give you a picture and everything. The last one that I'm going to ask you to do is one that is purely done in words. And what I'm going to encourage you to do is just draw a picture to start with, and then proceed like we were before. If you have questions, please stick around and ask them. But what I'm going to do is, we're going to do this a little bit differently, is that it's going to be assigned to you on this thing called Go Formative. When I do this, it should pop up as, I believe, an announcement or potentially an assignment. Look under classwork as an assignment on Google Classroom. So I'm going to assign it right now. Give me 1 second here while it's posting. All right. And as you are doing this, you're going to go to this Go Formative, and you're going to do Law of Sines, Day 1, Notes, Answer.